So we're going to talk about operations with functions, and tomorrow we're going to look at compositions of functions. So those are two different things. Neither one of them is brand new to you because it is definitely an Algebra 2 thing. However, one thing you did not do in Algebra 2 was focus on the domain. So the domain is the new part of this, so make sure you understand fully how to come up with what that is going to be. All right, so let's talk about what operations of functions mean. And there's two different ways you can notate it. It says functions can be combined using addition, subtraction, multiplication, division to create a new function. So here's one type of notation. This reads as f plus g of x. Another way to write that is f of x plus g of x. This is just kind of a condensed way to write it, but it means the same thing. You just take the two functions and you literally add them together. Then subtraction, f minus g of x would be the same as f of x minus g of x. And then you got to be really careful to watch your signs there. Multiplication, f times g of x. So this would be f of x times g of x. Write that correctly. This is different. There's going to be two symbols that look similar to this. There's that, which is a closed dot, and then there's one that's an open dot. So you got to make sure that you're paying attention to what that little dot looks like. And then f divided by g of x is the same as f of x divided by g of x. So those, again, basic things that you've done with functions before: add, subtract, multiply, and divide. The domain is what we have to really focus on here. So it says the domain of the new function is the intersection of the combined functions. So an intersection is not a passing through. It's what two things have in common. So the intersection of two streets, although you think if you're passing through the intersection is literally that little part in the middle that they both have in common. So the intersection of the two domains is what they have in common, what they share. So then the domain is further restricted with the quotient function, quotient meaning what? Division, to exclude values in which g of x equals 0. Now, let me be clear on this. This specifically says g of x equals 0. That doesn't mean it's always g of x. On these notes in particular, g of x is in the denominator every single time. What it really should say is whichever function that you're dividing by. Okay, so don't just assume every g of x ever is the one that you restrict it by. It's whatever the function is that you're dividing by. In this case, it's all g of x. On the assignment, it could be f of x, or on anything, it could be something different. But it's the function that's in the denominator is what you're restricting it by. Okay, so it's easy to get yourself mixed up in the domains within the functions themselves. If you look at it as a completely separate thing, it can really help you. So let's just take these two in particular to begin with and talk about what the domains of these are. So what is this? What kind of function is this? It's a quadratic. So what's the domain? Negative infinity to infinity are all real numbers. We're actually going to write the domains in these in set notation because there'll be quite a few of these where it's all real numbers except for like just one particular number. And that's a little bit easier to write in set notation. So we'll use set notation here. We can just say all real numbers. So what kind of function is this second one? Linear. And so what's the domain? All real numbers. No matter what you do to the line, it's all real numbers as long as it isn't a vertical line. Okay. Then it wouldn't be a function, but you know. So we've got all real numbers and all real numbers. So the intersection of those two domains is all real numbers. That's what they have in common, right? This one has all of them. This one has all of them. What do they have in common? Everything, right? So those are our domains. So now let's go and actually find some of these. F plus g of x. So I take f of x, which is x squared plus x, and add to it g of x, which is 3x minus 1. So once I add those together, I get x squared plus 4x minus 1. Can't do anything else with that. That is equal to f plus g of x. Make sure you are labeling your answers and you don't just box an expression somewhere. Then we have to state the domain. Well, the domain is all real numbers. It's what those two have in common. Easy enough? All right, so then I'd have f minus g of x. So f is x squared plus x minus, what do I have to make sure I do? Parentheses, 3x minus 1. Over here, I could have put them 2. A good rule of thumb is anytime you're substituting in something with more than one term, but with the addition, it really didn't matter. With the subtraction, it totally matters. Because this is going to give me x squared minus 2x, then what? Plus 1. That is equal to f minus g of x. And my domain is the same as it was in A, all real numbers. So then f times g of x, right? Well, f is x squared plus x times g, which is 3x minus 1. So when I multiply those together, x squared times 3x is 3x cubed. The outside 2, x squared times a negative 1 is negative x squared. Inside 2 would be a positive 3x squared. And last one is minus x. Can I combine some things here? Yep. So I get 3x cubed plus 2x squared minus x. That's equal to f times g of x. And my domain is still all real numbers. So then, on D, I have f divided by g of x. So f is x squared plus x over g of x, which is 3x minus 1. Can I reduce this at all? Can I cancel these x's out? No. And even if I factored the GCF out of the numerator, there isn't going to be anything that I can reduce, so I really can't reduce anything. This is equal to f over g of x. Now, when I look at the domain, it says that the domain of the quotient function is further restricted to exclude values in which g of x equals 0, or the denominator here. Now, I'm not just looking at this and trying to figure out what the domain is. You look at the original function. That is very important. Sometimes you get the same thing, sometimes you do not. You have to go with the original function. So I know, since I have f divided by g of x, that g of x cannot equal 0, because I don't get to divide by 0. G of x is 3x minus 1. So 3x minus 1 cannot equal 0. That means that 3x cannot equal 1, and x cannot equal 1/3. Which, if I looked at the domain of just my final product over there, it would be the same thing. You agree with that? Because the denominator can't equal 0. Okay, so you're solving the equation, but instead of having an equal sign or an inequality sign, you just say that it can't equal that. Ask me a question. Because we are dividing by g of x, and you can't divide by 0. Because it doesn't exist. No, oh my gosh, no. If you divide by 0, you do not get 0. You get undefined. You might. Yeah. Whew. Okay, so now that I have this, my domain is not all real numbers. It is all real numbers except I can't have 1/3. So my domain then is the set of all x's such that x cannot equal 1/3. Every time you have division, it's whatever function you divided by originally. You take the original one you divided by and figure out where it equals 0, because the next can't equal that. Yes, it's whatever, not this denominator, whatever this function is, which happens to be the same thing because I couldn't reduce it, but sometimes you reduce it out and it looks different. You take the original one. What other questions do you have? All right, so on this next one, we're just going to look at the domains. So I want you to talk amongst yourselves at your table and decide what the domains of these two functions are. And then I'm going to call on somebody to tell me what their table decided, so make sure you discuss it. I can help you with the notation as long as you can give me the information. All right, let's see who's going to help me. You're going to tell me what your table decided. All right, Lizbeth. Okay, so for the first one, what did y'all decide on this one? All real numbers. Okay, good. What did you decide on this one? Good. So 0 to infinity, and we include 0, right? So we're going to write it in set notation, though. You're correct about what you said. So I'm going to help you transfer that from it. That was interval notation. We're going to transfer that to set notation. So it's a set of all x's such that x is greater than or equal to, that's why you had the bracket, 0. Okay, do y'all agree with that? Did you at least have that even if you had it in a different form? It's okay. That's why we're also doing more than one form so we can get used to more than one form, but very good. All right, so those are our two domains. So remember, our domain for everything but the quotient is just the intersection of these two. So this one has all real numbers. This has only the numbers that are greater than or equal to 0. So when I put what they have in common is just this one. Does that make sense? So the domain here, and all we're doing is the domains on these. The domain here is the set of all x's such that x is greater than or equal to 0. Once you have the intersection of them, that's true for the addition and the subtraction. So the domain, the set of all x's such that x is greater than or equal to 0. And the multiplication, domain, set of all x's such that x is greater than or equal to 0. Then, how do I know? Because since I didn't actually do the work from the other stuff, because I want you to see that the domain is separate. Like I can still go back and multiply these and add them or whatever, but the domain is the intersection of the two original domains no matter what. Okay? It's the intersection. It's what they have in common. Mostly, yes. Pretty much. Of course, there's always exceptions. All right, so f divided by g of x. So g of x is the denominator. We're not doing these because I want you to see you don't take your end result. I don't even care what happens over there. What I do is I take whatever this denominator is, which is g of x, and say that g of x cannot equal 0. So the square root of x cannot equal 0, which means x cannot equal 0. Right? So is my domain for D the same as the other domains? No. How do I change it? I take away the underline. So instead of greater than or equal to 0, it's just greater than 0. So the domain is the set of all x's such that x is greater than 0. There are my domains. You don't have to you do have to do the work on the assignment because it tells you to do the work. But my point is, you do the work and you do their domains and think of them as two separate things so you don't make it harder on yourself. Okay? Are we good? All right, let's work through some other ones. Flip it over. Yeah, thank you very much. You've read my mind. What kind of function is this? Cubic. So what's the domain? All real numbers. And this is a what? Quadratic. And it's all real numbers. So guess what? The domain for A, B, and C, all real numbers. Okay, but we're also going to do the work on this. So for A, when we add them, we get g, which is x squared minus 4x, plus f of x, which is 2x cubed. And then, it doesn't look like a cube. So then when I combine them, there's really nothing I can combine. So it's 2x cubed plus x squared minus 4x, and that's equal to g plus f of x. Okay, in my domain, we just decided it's the combination of those two, so it is all real numbers. No overthinking there. Then I subtract. So I have f, which is 2x cubed, minus g of x, which is x squared minus 4x. Got to put that in parentheses so I don't mess up my signage. This is equal to 2x cubed minus x squared, then what? Plus 4x. And that's equal to f minus g of x. And I've already decided that my domain is all real numbers. All right. C. Multiply them. So I get f, which is 2x cubed, times g, which is x squared minus 4x. Going to distribute, so this gives me 2x to the what? 5th. That's fine. Minus 8x what? To the 4th. Equals f times g of x. And my domain is all real numbers. Then on D, I'm dividing f, which is 2x cubed, over g, which is x squared minus 4x. Misspoke there. Am I going to be able to reduce anything? Yes. So in the numerator, I have 2x cubed. I factor out an x in the denominator. You get x minus 4 And then I can reduce them both by x. So I'm left with 2x squared over x minus 4. And that is equal to f over g of x. Okay, now my domain could be all real numbers, but maybe not. I've got to go back up here and see what's going on. So I know that g of x, or whatever the denominator happens to be, cannot equal 0. So x squared minus 4x cannot equal 0. Easiest thing to do here is to factor. So x times x minus 4 cannot equal 0. So I know that x cannot equal 4. Is that it? And x cannot equal 0. Okay? Because you've got two factors there. Now, look back over here. If we'd have just taken our final product and tried to figure out what the restrictions are in our domain, the only one that shows up here is that x can't equal 4, right? That's why you have to take the original. Because, yes, x can't equal 4, but there's other stuff going on the graph that you don't know about yet. And so you've got to figure out, what's happening. So your domain then is the set of all x's such that x cannot equal 0 or 4. And there is your domain. So don't fall into the trap of just looking here. That's why you have to look at the original one that you divided by. Okay? We all good with that? All right, good deal. All right, y'all talk about the domains on number 4. Talk amongst yourselves. It's just domain. Oops. All right, let's see what your... All right, Rigo, what did y'all decide at your table for the first one? Set of all x's. Okay, good. Such that x cannot equal 0. Okay, do y'all agree with that? Okay, yeah, Rigo agrees with himself. All right, what'd you get for the second one, Rigo? Okay. Good. All right, y'all agree with both of those? Yes? Okay, very good. So it's a set of all x's such that x can't equal whatever. All right, so when I combine these two, so I have everything but 0 and everything but negative 2. So when I find the intersection of them, that means that it can't equal 0 or negative 2. Make sense? So all real numbers except for 2 of them. All right, so let's figure these out here. We're going to add. So f plus g of x. So I have 1 over x plus 2 over x plus 2. So when I add fractions, what do I have to get? Common denominator. Is that pretty simple here? Yes, it is. It's very simple. What is your common denominator going to be? X times x plus 2. So that means this first one, you have to multiply by x plus 2 over x plus 2. So we'll get x plus 2 over x times x plus 2. Plus, this one has to be multiplied by x over x. So I'd give 2x over x times x plus 2. Okay. So then when I add those together, that's going to give me 3x plus 2 over x times x plus 2. Can I cancel out those x plus 2's? No. Cannot do that. Can't cancel anything out. So that's it. This is equal to f plus g of x. And then my domain, we've already figured out, is the set of all x's such that x cannot equal 0 or negative 2. Yes, you use both of them. There's that light bulb. Yeah. There we go. Ding, ding. Okay. Then I have g minus f of x. So g is 2 over x plus 2 minus 1 over x. So once again, I have to get a common denominator. Well, I just did that, so it's not that big of a deal. I'm going to get x plus 2. Oh, no, I'm not. I'm doing the second one for some stupid reason. Hang on a second. I'm sorry. Okay. So this one I multiply by x over x. So 2x over x times x plus 2 minus x plus 2 over x times x plus 2. And here's what you have to be careful not to do. Don't get to right here and be like, oh, look, I can cancel these x's and I can cancel this. Because yes, you can, but then you're just in a vicious circle. Like you just put them in there. Don't take them back out yet. All right, so now when I subtract, my common denominator is going to be x times x plus 2. So 2x minus x is x, and then what? Minus 2. Good. This is subtracting this, so you have to think about that in parentheses or put it in parentheses. Make sure you actually subtract both of them. This is equal to g minus f of x. So then, this is the quotient. Oh, no, that is not the quotient. That is subtraction. We'll get to the quotient. That is the difference. So now I'm going to multiply. This is equal to g times, which is 2 over x plus 2, times f, which is 1 over x. Do I need a common denominator? No. If you get a common denominator, in the end, you'll get the right answer if you do everything right, but you're making a lot more work for yourself. You just multiply straight across. So in the numerator, you get 2. In the denominator, you get x times x plus 2. You don't even have to distribute. This is equal to g times f of x. It doesn't matter, it'll be fine. Oh, I forgot to do domain over here because I started talking quotient. Well, on both of these, your domain is the same. Domain x such that x cannot equal 0 or negative 2. And then the same thing here. Domain, which is a set of all x's such that x cannot equal 0 or negative 2. All right, so then we look at D. It's f divided by g of x. So f is 1 over x divided by g, which is 2 over x plus 2. So you have a fraction and a fraction. It looks super yucky. Should you freak out? No, it is not that big of a deal. When you divide, you multiply by the reciprocal. This is what we end up with. So then that is going to give me x plus 2 over 2x. Can I reduce that at all? No. So that is equal to f over g of x. So then I come over here and I say, all right, well, because I divided by g of x. G of x cannot equal 0. So 2 over x plus 2 cannot equal 0. To get that out of the denominator, I'm going to multiply both sides by x plus 2. When I do that, I get that 2 cannot equal 0. Well, is that a true statement? Yeah, 2 can't equal 0. But it doesn't, yeah, it's a true statement. But it doesn't give me the x that we're thinking that we should get, right? So let's think about why we get something weird. What is the parent function for this? 1 over x. So it's a reciprocal, right? And on the reciprocal function, your parent function, you have asymptotes here and here, right? This has a shift to the, which way? Left. So this one moves over here. Does this one move anywhere? No. So it stays right here on the axis. So is y ever going to be 0? Doesn't g of x represent y? So for that function, y is never going to be 0, right? That's impossible. That's why you get something weird here. So it doesn't change my domain any, and my domain is exactly what it has been, which is the set of all x's such that x cannot equal 0 or negative 2. And again, if you just took this at face value at the end, you'd just pick 0. You wouldn't even pick negative 2. Okay? So be careful with that. Go ahead. Ask me a question, Michael. No, ask me a question. Wait. Yeah. There you go. See, aren't you glad you asked? Now you know. It's all good. All right, come up with the domains for 5. Okay. Some tables aren't even talking, but whatever. All right, Michael. Tell me, what did your table come up with for this first one? Set of all x's. Uh-huh. Okay. And what about the next one? Okay, good. Do y'all agree with that? Okay, so I heard some different type of discussion. Twee, can you tell me when you were talking about it graphically, right? Did you look at it as a graph? Did I hear you right? Okay, because this is a square root function, right? And so sometimes algebraically it helps people. Sometimes it is, thinking about it as a graph. This is your parent function for a square root, right? And what does this do? Moves it to the left 6, right? So you would move over here, and this is here at -6. So you can see, if you understand how that function shifts, that it has to be everything, all the x's have to be greater than or equal to -6. And here, this is going to shift it to the right 2. So this is why this one is all numbers that are greater than or equal to 2. Does that make sense? So that's another reason why that helps. Now, last period, I got a lot of x is greater than or equal to 0. And then they couldn't get past that. Like they knew what was under the square root couldn't equal 0. Well, you can look at that algebraically as well. You just say, all right, well, I know that x plus 6, or actually, whatever's under the square root, which is x plus 6, has to be greater than or equal to 0. So you know that underneath there it has to be greater than or equal to 0. That's where you're going to get this from when you solve for it. So there's different ways to look at it, but understanding those parent functions can help you make sense of things. When you think it's one thing, and then you can picture it in your head and see that that's really what's happening. Okay, very good. So let's add these together. When I've got g plus f of x, so g is the square root of x minus 2 minus the square root of x plus 6. What did I do? Oh, plus. Oh, my goodness. Okay, there we go. Thank you. We're adding. I even said adding, and then I subtracted. Okay, so I'm adding those together. Can I actually combine anything? No, I can't. Like, that's it. So I'm done. This is g plus f of x. Now, my domain is the intersection of these two, which would be what? Yeah, so here's my number line, right? So here we are at -6, and here we are at 2. So I know that x has to be greater than or equal to -6. It also has to be greater than or equal to 2. So where they intersect, what they have in common starts right here. So it's just this part. Does that make sense to you? If you got to draw yourself a little number line to make it make sense, that's fine too. So it's the set of all x's such that x is greater than or equal to 2. So then we subtract them. F, which is square root of x plus 6, minus g, which is the square root of x minus 2. And again, I can't do anything, so that is f minus g of x. Always make sure you're paying attention to which order you're subtracting so you don't do some ridiculous mistake. So our domain is the same, set of all x's such that x is greater than or equal to 2. Then I'm going to multiply them, g times f of x, so the square root of x minus 2 times the square root of x plus 6. Can I actually combine these? Yes. Do the square roots get knocked out? No. Everything underneath the square root can be multiplied together. Everything outside the square root can be multiplied together. The only time the square roots get knocked out is when you multiply two identical things, and these aren't identical. So this is going to be just foiling, basically. Think of them as having parentheses. So it's going to be the square root of x squared, and then I'll have a positive 6x and a negative 2x, so that's plus 4x, and then minus 12. That is equal to g times f of x. Okay, and my domain is the same. Set of all x's such that x is greater than or equal to 2. Then we have the quotient, f divided by g of x. So f is the square root of x plus 6 over the square root of x minus 2. So I can divide everything that's under the square root together, but even if the square roots weren't there, is there anything I can do? Nope. So this is it. This is f over g of x. So then I have to take another look at the domain. What I divided by, which is g of x, cannot equal 0. So the square root of x minus 2 cannot equal 0. So x minus 2 cannot equal 0, and x cannot equal 2. So does that change my domain? Yes. Now it's going to be the set of all x's such that x has to be what? Greater than 2, because I don't get to include that anymore. There you go. All right. What questions do you have? Michael, what questions do you have? Are you? Okay. Making sure. All right. So now we're going to evaluate. We don't have to worry about domain or anything. This isn't f of x, it's f of 5. And so this is the same thing as f of 5 plus g of 5. So if you just substitute it in as you go, works out nicely. So f of 5 means substituting 5 in here. I'm going to get 4 minus 5 squared plus g of 5, which is going to be 2 times 5 plus 8. So then this becomes 4 minus 25 plus 10 plus 8. So if I do negative 25 and positive 4, it's going to be negative 21 plus 10 is negative 11 plus 8 gives me what? Negative 3. So f plus g of 5 equals negative 3. See if you can work out b while I hand out the homework, and then I'll talk with you. No, it's not asking you for the domain or anything. You're just evaluating the function. All right, so what did y'all get? 0. And 0 is a perfectly fine answer. Sometimes when y'all get 0, you freak out because you think it's wrong. But once I figured out that this first part was 0, did it even matter what was happening with this? Nope, sure didn't. This is your answer. All right. What questions do you have? Yes, sir. All right, so you have about 10 minutes left. That's what the little bell meant. So make good use of your time.